Well, ladies and gentlemen, let's do a brief factor review. Factoring is going to be a part of chapter 2, and the assumption is just going to be that you know how to do it. So that is a problem if you don't know how to do it. So the first thing that you always want to check for is the GCF. I call it the gotta check first. And what that's going to really mean is your greatest common factor. So if that's something that you can pull out of a problem, because every single problem, or excuse me, every single number in there has, a value that can be taken out, then you do that first. Once you've done that, you're going to be looking at whether it has 2 terms, 3 terms, or 4 terms. Because at this point, if it's 2 terms, you're looking for it to be what we call the difference of 2 squares, where it's the difference, subtraction, of 2 things that are perfect squares. And then that would break down or factor into a plus b, a minus b. So a simple example of that would be x squared minus 9. It's the difference of 2 perfect squares. This is going to be the perfect square of x, and this is the perfect square of 3. So my factors are x plus 3, x minus 3. So that is the only one that we're going to be worried about right now, kind of responsible for, is breaking down that difference of 2 squares. Otherwise, if it's 2 terms and it doesn't have a greatest common factor, there's nothing else that we can do. 3 terms, we'll save that. Well, I guess we'll take a look at that first. So 3 terms, there's kind of 2 types of these. One is the type that you do pretty regularly, usually pretty straightforward. I think it's what you think of when you think of factoring, x squared plus 3x minus 10, for example. And what I always recommend you do is you think about what makes 10 in terms of multiplying. So 1 times 10 or 2 times 5 are your options. And then I always say to look at this. This tells you how they're going to combine to make this middle number. So in this example, I would need one of these 2 pairs that would combine through subtraction to make 3. Well, 10 minus 1 is 9, so 5 minus 2 gives me the 3 that I need. So when I break this up, I have an x times an x, a 2, and a 5, and then I look, excuse me, that's awesome. I look at this and see that it needs to be a positive 3. So that has to be plus 5 minus 2. So that is the thing that I think we think of when we talk about factoring. And so some people are great at it, some not so much. You do want to make sure that you're paying attention to this last term. Say that I had a minus 5x and then a minus 6. I'd be looking for ways to make 6. 1 times 6, 2 times 3. Now everybody grabs up 2 and 3, but if you pay attention to what I said before, it has to subtract to be 5. So I would actually need to choose the 6 and the 1 in this case. And then in order to get a negative 5, I would need a minus 6 and a positive 1. Whereas if I had something really similar to that, and I had, let's say, x squared minus 5x plus 6. All I did was change that last sign. I still am thinking of my factor pairs for 6, but now they do have to add up to be 5. So I would choose the 2 and the 3. So it's just really picky stuff like that. And now in order to get the negative 5, they would both have to be negative. So you do have to pay attention to all of the signs, plus, minus, and just kind of be real cautious about that. Now, there's another type of 3-term factoring, and that is when there's a number in front as well. So we say the a does not equal 1 because we look at ax squared plus bx plus c as our quadratic. So I have kind of a cheaty way of doing this that I will share with you, and you can do it this way if you'd like. If you've learned a different way in the past, maybe you've learned a snowflake method or something that works for you, do it that way. I'm not here to change something that's working for you. So what I do is I sort of do a little sneaky attack. Oops, that's not it. I sort of take these 2 and I multiply them together. Now, this 2x squared, I write here and here for now. I can't leave it as that because obviously those two would make a 4x squared, which I don't want. So I'm just kind of beefing this up to work with, and then I'll reduce it back down later. So what I do here is I pay attention to both the first and the last number. I multiply them together and get that 6, and then that is going to be the number that I split just like before. So again, 1 and 6, or 2 times 3, and in this case they need to subtract to be 1. Well, only 2 and 3 would subtract to be 1, so I choose 2 and 3. To get a negative 1 out of those, I would need a -3 and a +2. So that way I don't have to do guessing and checking trying to sort it out, but the key is if you do it this way, you'll have to reduce one if not both. Now this particular one, 2x minus 3, doesn't reduce, but here you can see that I could divide a 2 out of both of these, so that second factor would reduce down to be just an x plus 1. And if I wanted to go ahead and FOIL this, I could check that this does indeed come out to be what I started with. I'm going to do one more example of those because I think those can be kind of tricky, especially if you haven't seen it done this way before. So say I had 2x squared minus 5x plus 2. So you notice that there's a number in the front, and you copy that 2x here and here, multiply the first and last number together, and then split that up. So 1 times 4 or 2 times 2, you need them to add up to be 5. Well, 2 plus 2 is not 5, so you're choosing the 1 and the 4 in this case. And in order to get a -5, you need them both to be negative. But at this stage, you need to reduce. This one doesn't reduce, so it stays 2x minus 1. Here I can divide out a 2, bringing this down to x minus 2. So that's kind of a tricky thing, and you might need to refer back to this later if you want to use that method. Then the only other thing is going to be 4 terms, and I'm not sure I left myself enough room here. This won't come up a ton, but what we did back in the good old days when we learned how to factor these, we did them by grouping. And with grouping, you basically split it down the middle. So this is when I have 4 terms. So there's not a lot of different ways. You really just have to be able to count. And so if you see x cubed minus 3x squared minus 5x plus 15, and I'm sorry, I'm cramming this in here. That is pretty messy at the end. Then you can say, all right, I'm going to have to do grouping. I don't have any options because I have 4 terms, 1, 2, 3, 4. And so if you'll remember this, maybe you split it down the middle. You literally think of it as 2 separate parts, and then you do the greatest common factor here and the greatest common factor on this side. So for these 2 terms, x squared is the greatest common factor and would leave me with an x minus 3. For these 2 terms on the other side, if this is a negative out in front like it is, you do have to pull that negative out. And then you can see that 5 goes into both of these. If you divide a -5 out of -5x, you'll be left with x. And then be careful, if you divide a -5 out of 15, you'll actually get -3, which is good news because with grouping, these 2 have to come out to be the same. And then what you think of is saying, okay, well now these 2 have sort of become the common factor, so that comes out in front, leaving you with, as the other factor, x squared minus 5. So I don't expect you to just be like, oh yeah, I totally remember all of these things, but you want to be able to kind of hopefully practice a couple in order to do that. I'm going to do one more of these as well. If I had 2x cubed minus 3x squared plus 4x minus 6, I would notice that it's grouping because there's 4 terms. And if it doesn't work to group it, then it's not going to factor, but I'm going to certainly try. The only thing these have in common is an x squared. When I divide it out, I'll be left with a 2x here and then a minus 3. Over here, I only can pull out a 2, it looks like, which is good because that would, when I divide the 2 out of these 2 terms, leave me with 2x minus 3. That makes me super happy because these 2 are the same. So then those two can become my common factor, and my other factor will be those parts that I pulled out in front. So that is a messy sheet of paper, my friends, but that's kind of just our general approach to factoring. And so you are going to be working on some IXLs before you come to school or have the in-class lessons on Chapter 2. And that way you can kind of be practicing this. Chapter 2 is not about factoring. It just assumes you know how to factor. So you want to go into IXL and practice some of that so that when we get to that portion of Chapter 2, it's not a big deal for you to hop in there and do those problems. Have a great day. Bye, guys.